This is the third and final part of the video series Completing the Square, and this one's about solving quadratic equations. But first, a quick reminder of the previous two videos. Video 1 showed you a helpful picture of how a square can be drawn. For example, is x squared plus 6x plus 9 a square? Well, let's see if we can arrange it into a square shape. Here's the x squared. I'll slice up the 6x into these two rectangles, 3x and 3x, and pop them here and here. And the number term, the 9, can be drawn as this 3 by 3 square and popped in the corner. So yes, x squared plus 6x plus 9 is a square, and it's the square of x plus 3. Video 2 set out a mathematical rule for completing the square using algebra. Supposing you're given, say, x squared plus 8x, here's how to work out what number to add to complete the square. Take half of the 8, that's 4, then square the 4, and there's the answer, 16. By adding 16, you get x squared plus 8x plus 16, and this is indeed a square. It's the square of x plus 4. Well, that's the background. I'm now going to show how the trick can help you to solve quadratic equations. Here's the first example, x squared equals 25. Look at the left-hand side of this equation, the x squared. You don't need to complete the square because x squared is already a square. Taking the square root of both sides, you get x equals the square root of 25, and there are two answers, plus 5 and minus 5. Now try this one. X minus 3 in brackets squared equals 36. Again, this is straightforward because the left-hand side, x minus 3 squared, is already a square. As with the previous example, just take the square root of both sides. So x minus 3 is equal to the square root of 36, and that could be plus 6 or minus 6. Add 3 to both sides, and the two solutions are x equals 9 or minus 3. And now let's try something a bit harder. X squared plus 4x equals 12. Unlike the first two examples, the expression on the left-hand side of the equation is not a square. Luckily, we do have a trick to make it square, and that trick is, you've guessed it, completing the square. Half of 4 is 2. Square this to get 4, and I know that by adding 4, I'll complete the square on the left-hand side. And this is the square of x plus 2. But what I do to one side of the equation, I must do to the other. So add 4 to the right-hand side, giving 16. And now I am able to take the square root of both sides. X plus 2 is equal to 4 or minus 4. Finally, subtract 2 from both sides of each equation, and x is equal to 2 or minus 6. I'll check that these two solutions are correct. Taking the x equals 2 solution, substitute this value into the original equation, and I get 2 squared plus 4 times 2, that's 4 plus 8, and yes, that is equal to 12, so x equals 2 is a correct solution. And now x equals minus 6. Minus 6 squared is 36. 4 times minus 6 is minus 24. Put them together, and yes, I do get 12, so x equals minus 6 is a correct solution. And now one final example. 3x squared minus 18x equals 21. If I take out a factor of 3, I get this. It will simplify things if I divide right through the equation by 3, and this gives x squared minus 6x equals 7. And now I'll complete the square on the left-hand side. Half of minus 6 is minus 3, so to complete the square I need to add minus 3 squared, and that's 9. And to keep the equation balanced, I need to add 9 on the other side. So that gives, finally, the square of x minus 3 is equal to 16. And now I can take the square roots of both sides. X minus 3 is the square root of 16, which is plus or minus 4. So x is equal to 7 and minus 1. Now, there are other ways of solving quadratic equations, but that's how to do it using the method of completing the square.